Hello everybody, I hope everyone's doing well. My name is Austin Taylor and I am a member of Group 1 along with Parker McComas, Daniel Brandao, Josh Deighton, and Jake Thompson. And our group project for CSC 382 is going to be on a mobile banking app for the UMF Credit Union. The customer for our project is the University of Michigan Flint UMF Credit Union. UMF Credit Union is a local credit union in the area, and they would like to increase their customer base and gain more of a competitive edge. However, there are other local credit unions who are also seeking to increase their customer base and competitive advantage. UMF has been one of the larger and more trusted of the credit unions in the area. However, with today's modern era of increased use of technology, they are struggling to maintain their competitive advantage, as they do not have a mobile banking app in place as some of their competitors do. UMF currently does all of its transactions and services face-to-face or on their website, and a majority of their customers are middle-aged to older adults, and they are seeking to attract more of the younger adults to join their credit union. The UMF Credit Union is not technologically illiterate, as they have computers to keep track of the transactions and customer records, which is stored in their database. In order for the UMF Credit Union to attract more customers and to stay competitive with their loan rates, they have to reduce their large overhead and operational costs due to being an in-person and web-only business. They would like to incorporate software that allows their customers to manage their day-to-day banking tasks on a mobile device. UMF Credit Union has taken a look at some of their competitors' mobile banking apps they have in place, and have come up with an idea of the features they would like their own mobile app to be able to do. They would like their system to be fully web-based and able to connect to their current database, and also reflect the look and feel of their website. Additionally, the system should allow for customers to create and update their accounts, check their balances, transfer funds between accounts and external accounts, check their spending and deposit history, order personal checks, receive statements and forms via email, and chat with a UMF Credit Union associate online to answer any questions the customer may have. They would also like to include features that take advantage of mobile devices, such as depositing checks using your device's camera, utilizing external digital payment networks such as Zelle or Venmo, and locate any nearby ATMs by using your phone's GPS. By developing the software for a mobile banking app option for their customers, they will decrease the amount of overhead and operational costs. They will also gain more time on pertinent operations that are taking place in the UMF Credit Union, which will help cut down on the employee hours. Another benefit of developing software for a mobile banking app is that more of the processes are now automated, which gives employees more time to focus on customer service. All of these additions will greatly increase UMF's competitive advantage, and by having a mobile option will help attract more of the younger generation. Not only does this attract more of the younger customers who prefer mobile apps, but it will help to retain customers who might be afraid to go to the credit union in person because of an outbreak of disease, like the COVID-19 pandemic. Our company, Imagine Tech Corporation, has been tasked with providing UMF Credit Union with a mobile banking app software solution for their current needs. Our company has had a great deal of experience working with banks and developed customized software to help give them a competitive advantage in the world of technology. Additionally, Our company is very well known in this area and trusted by most businesses, as we deliver high quality software and are industry leaders in the Midwest. We offer competitive pricing without any hidden fees. Our company is known for its customer service and following through on the deliverables that our customers want. We are the software solution. Here we have the overview of our project system architecture. The diagram to the right illustrates the system architecture for the UMF Credit Union mobile banking app. When a user would like to use the UMF mobile banking app, they use their smartphone or other device to open the app, which then connects to the internet to connect to the UMF web server, where they can perform a variety of operations. These operations the user makes are recorded in the UMF database, and the information and changes the user makes to their account are saved in the database. And then a reply is sent back to the user to indicate the successfulness of their requested operation.
This is our use case diagram for the UMF mobile banking app. It helps visualize all the ways the users or clients will interface with the application. This illustrates the primary user will be the customer or clientele with UMF that is using the application. And of course, the secondary actor is the UMF credit union itself. To the right, you will see our class diagram for the UMF mobile banking application. It helps illustrate the layout of classes within UMF's banking application. It tries to depict the main elements that make up the UMF app, along with the interactions, and serves as a kind of blueprint that will help the programmer implement the application in actual code.
Continuing with our software requirements, we have behavioral models, which includes a state diagram and a sequence diagram. The state diagram illustrates how the state of action changes as the user interacts with the UMF mobile banking app. The user first opens the app and initiates the login process to access their account or create a new account if they do not have one. When the user logs into their account, it goes through the authentication process where their account ID and password must be validated to access their account. If the user's login is incorrect, the login fails and the user is returned to the login screen where they can try to log in again. After they have logged in successfully, they can proceed to their account to perform their banking tasks. Our state diagram shows how active states change depending on the events triggered by what account operations the user initiates. If the user initiates the transfer funds operation, the state of the class can change from withdrawing funds from the account or depositing funds into the account utilizing their phone's camera to deposit their check. After the user has finished their banking task, they can proceed to view their account statement and then log out and close the app. Here we have our sequence diagram, which illustrates how the user interacts with the UMF mobile banking app and the sequence that the events occur. The user first opens the UMF mobile banking app, which connects to the UMF web server and begins the login process. Once the user has successfully logged in, they can select an operation to perform using the app. If the login is unsuccessful, an error message is displayed to the user. After the user selects an operation to perform, the UMF web server retrieves the requested data and the information is displayed on the app. Any changes the user makes to their account is updated and saved in the UMF database. After the user is finished with their banking tasks, they can proceed to log off and close the app. As you can see, a majority of the interactions between the objects occur between the mobile app and the web server throughout the length of using the app.
These are some of our data flow diagrams. To the right, you can see our level 0 or context diagram that tries to give an easy stripped down overview to how the data flows through our system. The level 1 diagram helps to further illustrate this relationship by having more entities involved with the flow of the data. This is our level 2 data flow diagram. It tries to give a deeper understanding to how data will actually flow through our system by showing the flow of the application, starting with the user or client trying to perform an action that the app is designed to handle, and then stepping through that process little by little.
The application architecture is a multi-layered approach, as this is the most common for mobile applications. The outermost layer is a user interface layer, which contains all visuals that a user interacts with. The UI layer includes a login screen with username and password fields, a register screen with fields such as username, password, address, and social security, as well as other components such as view account details, deposit check, and register. The business layer is the middle layer, which includes the business logic that executes upon UI actions. The business layer includes logic to find customer details, logic to edit and update existing information, as well as logic to upload images and extrapolate financial details from the check image. At the core, the data layer consists of clusters of databases that are separated into 4 categories depending on functionality. The data layer consists of account details, which houses non-private information such as customer name, financial information including balances and transaction history, check images from deposits along with extrapolated check data, secure details such as password and social security number. The detail class model includes stereotypes and multiplicity details. Some stereotypes for our classes are the actor stereotype for the user class, the boundary stereotype for the UMF banking app class, and the control stereotype for the ATM map and remote deposit classes. For the multiplicity details, starting in the middle, a remote deposit inheritance can only happen one at a time, kicked off by perform new task. An ATM map inheritance can only happen one at a time, kicked off by perform new task as well. A user may register for multiple accounts and be logged into multiple accounts, but they must have at least one account to perform actions. User information cannot be duplicated across multiple accounts and must have at least one unique user ID. An account ID can only belong to a specific user. A user may have multiple bank accounts associated to their account, but the account must have at least one bank account associated. A transaction must be associated to at least one account, but there could be multiple transactions with similar details. A bank account can also exist without ever executing a transaction, as rare as they may be. And it can also have multiple transactions throughout its life cycle.
So this is the first part of the detailed behavior models, and these are detailed state diagrams, which provide more details for some of the parts from the state diagram in the behavior model of the software requirements section. This first one on the top left is for any external payment methods. The user selects the external application to connect to, and if the connection to the external application web server is successful, the user can perform their desired task. If the connection is unsuccessful, the user is returned to the previous screen with an error message. This next one on the right is for finding ATMs. Shows their attempt to try to locate ATMs near them through their phone's satellite or GPS. If any ATMs are located, they are displayed to the user. If no ATMs were found, a message is displayed stating no ATMs are in the user's location. And that last one on the bottom is for check balances. This diagram shows how the state of the action changes as the user access their account to check their balance. If the user has funds or does not have any funds in their account, the amount is displayed. An error is displayed if the balance is less than 0. This is Detailed Behavior Model, Part 2. And this is basically just our sequence diagram from before that one of our other group members created. And it's basically the same thing, except I added if an ATM operation. And we'll just go through it again real quick. You've got the actor, you've got the UMF mobile app, you've got the web server, you've got the UMF database. And then it's open app, request login, connection successful, connection unsuccessful, connect to server. Then you got login entered, verify login. And you've got if login successful, else display message, login successful, login unsuccessful. And this is the part I added to give it a little more detail, is I added an actual operator. The other one just had select operator. So we've got select operator, and then the operator is if ATM operation is selected, it's finding an ATM near the user's location. You've got display message, connection successful, connection unsuccessful, retrieve data, send data, display data, make changes, same changes. And the last one is if operation is successful, display mention, else, display error, operation successful, operation unsuccessful, changes saved successfully or changes not saved, and then log off and close app. And that is our detailed behavior model of a sequence diagram, detailed sequence diagram. Thank you. So this is our text description for various methods from the class diagram. And starting out, we've got class, U of M, credit union, web server, method, authenticate account. This method is used to authenticate a user account and password when logging on through UMF app. Then next we have UMF credit union, web server, method, create account, description. The method is used by UMF credit union, web server to get and store new data for a new account. Next one, class, UMF credit union, web server, method, remove account. This method is used to remove all information about the user from the UMF app. Next, class, UMF credit union, web server, method, verify check, description. This method is used to verify checks that have been deposited remotely using the camera deposit feature on the UML app. Next, class, UMF banking app, main activity, log method, login, description. This method is used by class to log in to the user's specific account. Next, class, UMF banking app, main activity, method, register, description. This method is used by the class to register new users for an account. Works directly with the subclass UMF credit union UMF credit union web server method create account. Next, class UMF banking app main activity, method, perform new task, description. This method is used by the superclass UMF banking to perform any new task the user directs the app to do. Next, class remote deposit, method, take photo, description. This method is used to take a photo of checks on the UMF app for remote deposit. Next, class ATM map, method, get location, description. The method is used to retrieve the user's mobile device location if able. Class, next, class ATM map, method, display ATM map, description. This method is used to display the location of all ATM locations within a specific range of the user's mobile device location. Next, class user, method, get name, description. This method is used to ask the user to input their name. User, set name, class user, method, set name, description. This method is used to set the name string as whatever the user input during the method get name. Next, class user, method, get address, description. This method is used to ask the user to input their address. Next, class user, Method, set address. Description. This method is used to set address string as whatever the user inputted during the method get address. Next, class, bank account. Method, get balance. Description. This method is used by the class to retrieve the balance of the user's account from balance float. Next, class, bank account. Method, get account ID. Description. This method is used by the class to retrieve the account ID of the user's account from account ID int. Next, class, transactions. Method, deposit. Description. This method is used by the class to deposit money into the user's bank account, either remotely through the UMF app or at UMF Credit Union. Class. Next, class, transactions. Method, withdraw. Description. This method is used by the class to withdraw money from the user's account by either ATM or at UMF Credit Union. Class, transactions. Method, transfer funds. Description. This method is used by the class to transfer funds from the user's account into another specific account. So this is our deployment diagram for our project of the UMF banking app, and it's pretty simple because there's not a lot of components or actual devices that go into a app that is mostly data and software. So to start off with, we have our main big device, which is the mobile device, and then within the mobile device we have devices such as touchscreen, keypad, camera, speaker, and Bluetooth, so the app can be fully functional with the mobile device and use everything. And then we've got our executional environment, which would be the actual UMF banking app, mobile device app. And then we have our component account verification, which is to do anything you have to get to do anything within a deployment diagram, the component has to be there to start it. So that's why it's component verify account, so it can actually verify the account. And then below that, the artifact and deployment specs is going to be your software, your code to get it all done, stuff like that. And then it goes up to artifact app setup, and then that activates the component verify account, so you can actually verify the account. And over to the right, we have the device of UMF Bank Server, which gives the app all of your information, like account information, account verification information, check transfer, and ATM locations. And that's our little deployment diagram we have for our banking app. Thank you for listening.
Once we set out on this project and deploy it into the market, UMF Credit Union will find great success in their mobile banking application. Apps such as this one are attractive additions for young adults looking to open new bank accounts. Indeed, some young adults may even say it is a necessity in this technologically driven age in order to sustain a competitive foothold in the market. But we are confident that the UMF Credit Union, with the help of this mobile banking application, will be able to greatly increase their young adult clientele and maintain its competitive loan rates. This concludes our presentation for our group project. I would like to thank everybody for watching and have a great day.